Yeah. Good evening, ladies and gentlemen, fellow alumni and guests, and welcome to this, the inaugural Alumni Festival debate. What a time, what a week to be debating public opinion and science. I'm so glad you're here. I'm Catherine Galloway from the Kavli Centre for Ethics, Science and the Public here at Cambridge. We're your hosts tonight. The debate and this particular rather fiendish motion was our idea. The Kavli Centre exists as a space where we can think together about developing science and technology that is shaping the world we all share. We're guided by some very simple questions. What kind of future do we want? And who gets to decide? Will that future be ethical and beneficial to everyone equally? Will it feel uncomfortable? Will we be wringing our hands about unintended consequences or celebrating developments that make life exponentially better for the largest number of us? Will it be, rather messily, all of the above? When I think about these things, I think of Altachero, an American professor of law and celebrated bioethicist. Chero says, often you don't realize you're in the middle of a revolution until after the revolution has occurred. As a journalist, I'm used to reporting from the midst of revolutions. My job often involves trying to make sense of a moment in the eye of a storm. That is where news lives. But when we talk about today's science and technology, it feels important to open up big conversations just ahead of that revolution so that we still have time to work out what we think and want and why. And when we open up those conversations, what if we invited everyone? What difference would that make to the science and to wider society? The people addressing you tonight are really busy people. You can read their full bios, packed with deeply impressive achievements and responsibilities, in the Alumni Festival programme entry for this event. But in headline terms, they make the life-saving vaccines in our arms and the teeny tiny materials that make things work better. They advise governments and vice-chancellors and think tanks. They oversee multi-million-pound grants. They lead departments and labs. They found centres, chair boards, give interviews, write books, and guide the next generation of students. Sometimes they do all of that before breakfast. Two of them work at the cutting edge of cutting-edge science, Catherine Green and Jeremy Baumberg. Two of them make sure that that science and technology keeps happening, and happening in the most ethical, beneficial, and effective way possible in universities, in industry, and beyond. Sarah Chater and Rima Patel. And two of them ask wider questions of that science and our society. Where are we going? And why? And why does it matter? Tim Lewins and Lindsay McGoy. In short, the 6 speakers you will hear from tonight spend all day, every day, thinking hard about hard things. But they also sit next to us in hospital waiting rooms, curse their laptops for failing at just the wrong moment, travel with us on the underground, worry about their aging parents and growing kids, and watch the news at the end of the day with a mounting sense of, I'm sorry, what now? Because they are the public too, just like us. Not all of us here have degrees or careers in science, but we all have a stake in the kind of world that science is creating. We all, therefore, have a right to be part of the conversation, but that doesn't mean we are always right. In certain corners of the internet, we are almost definitely not. So as I wrote in your Alumni Festival programme, isn't it time we talked about it? Maybe even disagreed on it. Maybe changed our minds about it. Maybe found a new way forward together. This is why we're here this evening. So with huge thanks to our fantastic Kavli Centre team, Mariam, Daniela, Claudette, Richard and Anna, and to the Alumni Festival and Events team led by Claire and Jessica, I'm going to hand you over now to the Vice President of the Cambridge Union, Roberta Rennie, and her side chairs, Ben Davidson and Joshua Dargan, to get this event and this debate underway. I wish you a wonderful evening.
Good afternoon, all. Thank you so much for being here tonight. We are so incredibly pleased to see you all for what will comprise the first debate between, of course, Kavli Centre, the Cambridge Alumni Festival, and, of course, the Cambridge Union. Tonight, we are discussing quite a controversial topic, the motion being that this House believes that public opinion has no place in science. Of course, coming off the back of the COVID-19 pandemic and recent discussions on vaccines and medications in our society, this is something that is particular importance. As mentioned before, my side chairs include Joshua Dargan taking the minutes in front of me, who is our treasurer, and of course next to me is Ben Davison, our executive officer, and of course here is Catherine from the Kavli Centre. To begin tonight, we have 6 amazing and incredibly well-experienced speakers. We have first Catherine Green, second we have Jeremy Baumberg. We also have Professor Lindsay McGoy. Third, of course, or in opposition, we have first Ruben Patel, Tim Lewins, and of course Sarah Chater. To begin, we'll begin in proposition of the motion. So to begin, Professor Catherine Green. Professor Catherine Green, OBE, is Professor of Clinical Biomanufacturing at the University of Oxford. She formed part of the team that developed the Oxford AstraZeneca COVID-19 vaccine, and she speaks widely about her experiences of hard work and cutting-edge science in a race against the virus. Catherine is a cell biologist who primarily researches medicines, manufacturing, and of course creates vaccines for clinical trials. Catherine Green, you have the ears of the House.
As you can see, I broke my leg. It was on a hen do, but apart from that, the details are remaining confidential. After some wheelbarrow transportation, I was safely delivered to the A&E at the Royal United Hospital in Bath, where I received excellent expert care from a team of highly qualified personnel. Now, I don't imagine any of you would be disappointed to hear that I would state there was no place for my opinion, being a non-expert, in deciding what tests I needed, in analysing my x-rays, or in setting my cast. In the next 8 minutes, I intend to convince you that public opinion has no place in science for the same reason that my opinion has no place in the diagnosis or treatment of my bimalleolar ankle fracture. Reasonable decisions about the doing of science require training and expertise that we, as the public, simply do not have. First of all, I'll set a few limits on my argument, if that's okay. I'm a professor at Oxford with a specialism in cell biology, but don't panic, I am also a Cambridge alumni, Churchill and Christ's, so I have some legitimate reasons to be here. I'm not only from the dark side. I have 25 years of experience, post-PhD, working as a scientific researcher, 20 of those in fundamental basic research, trying to understand the world, and 5 in more applied scientific principles, complex manufacturing process and vaccine manufacturing. I feel I'm well placed to talk to you about the doing of science, the process of finding things out. I'm not really qualified to talk to you about how public opinion should organise policy or ethical dilemmas inherent in certain scientific disciplines, but there are some great experts in this room today who are far better qualified than I to discuss those, so we can leave that there. I'm limiting myself to answering the question, should public opinion influence what types of discovery science get funding? Because it is, of course, funding that determines what or whether science gets done. I'll give you a couple of examples from my research life. Should we spend taxpayers' money analysing chimpanzee poo? Should Cancer Research UK support a PhD student who's really interested in the sex life of yeast in molecular detail? It might be very easy for a layperson to say, No, surely there are more important questions, more important things to spend our money on, more direct relevancies to obvious problems in our society, more research, more likely to have bigger impacts in the world. Well, yes, perhaps, but therein lies the challenge, because some scientific research is fundamentally the answering of things that we don't yet know the answers to, the exploration of ideas that are not yet solidified into facts. And if we limit research to the obvious, to the fashionable, to the predictable, we narrow our opportunities for discovery. So as a PhD student in the 1990s, I was awarded money to work on genetic circuits in the baker's yeast, Saccharomyces cerevisiae. My supervisor, Imperial Cancer Research Fund scientist as it was then, was looking at the genetic control of the yeast life cycle, how you get a turn a gene on, how you turn a gene off in response to particular stimuli at particular times, particularly after irradiation. When I tried to explain to my mum or to my friends in the pub what I was doing with my time, they clearly considered that was a pretty niche argument. But within a few years of my PhD, the genome sequencing revolution had come along and made it really clear that virtually identical genes exist in humans to those genes I had been studying in yeast. Their proper functioning is critical to our cells' ability to respond to DNA damage, to deal with mutations of our DNA. And the work that I was doing in yeast, or seemingly peculiar or other esoteric organisms, has directly contributed to our understanding of how diversity is built in our immune system, how tumour suppressor genes work, and this has directly led to the invention of targeted therapeutics that are first-line cancer treatments for breast cancer today, olaparib or Lynparza. And the researcher in the 1960s studying the chimpanzee poo was able to extract a previously unknown virus, propagate it, identify it as highly similar to a human virus called an adenovirus. Complicated genetic engineering in Oxford to make it safe and to adapt it to human culture meant that that virus became the backbone of ChAdOx1, which is the viral vector backbone that we used in Oxford early in 2020 to design and then deliver 6 billion doses of Oxford AstraZeneca vaccine, saving approximately 6 million lives worldwide. Sometimes you find the answers where you least expect them. These real-world outcomes may well not have been possible had public opinion disapproved of and been allowed to veto studies of baker's yeast genetics or chimpanzee stools. And that's just too directly related to my work. There will be hundreds of other examples in other fields. Can we know that these foundational studies would not have been funded if public opinion had been the route by which research was selected? No. But we do know that the system that we did use, which is scientific peer review, did permit it. Peer review is a lot of work. My colleagues on the benches will attest to that. It in itself is not really free of bias. To allocate the £9.9 billion spent by the UK government via UKRI, that's the funding mechanism for taxpayers' money being spent on R&D, the UKRI last year analysed 30,550 applications, and it awarded 5,667. That's a lot of assessment, most of it done by people like us in our spare time for free. We have other jobs. We could be doing other things. So I question whether the inclusion of public opinion would improve this process, and I contend that it wouldn't, because we need our expertise to navigate this complex world. We can't all be qualified to assess specialist areas. I am not in any way knowledgeable about climate science or astrophysics. As a member of the public, I readily acknowledge that I'm not well placed to assess rigour or novelty or feasibility of research undertaken or proposed in these fields. To maintain our excellent science base, scientists should be allowed, encouraged to do interesting work free from financial, political or fashionable influences, whether those influences come from the public, from politicians, or even from scientists ourselves, because scientists are only human after all, and we are influenced by trends, by our own egos, by our prejudices, by the colleagues that we work with, by the politics of the day, and by perception of certain fields of science as perhaps more fundable, more likely to win a coveted grant that will enable me to pay my team and pay my mortgage. Does doing cancer research with a plausible link to drug discovery make me more likely to have a job at the end of the year, rather than if I followed my actual passion for worm ecology? Well, realistically, yes, it might. And this can influence scientists' decisions about what we study. The bigger picture might say we shouldn't neglect unfashionable areas where unknown discoveries await, but that's not always the reality in which we live. So given then that scientists and pervasive structure of peer review can, as well as public opinion, be biased, should we even consider eliminating opinion entirely from the process of allocating research funding, even expert opinion? Instead of the lengthy process of peer review, why not use a lottery after some baseline thresholding for making sure that quality of grants is above a certain threshold? So recently, this has been tried. A number of funding bodies, including 2013 to 2020, the Volkswagen Foundation, which also did it as part of an experiment directly comparing peer review to a lottery approach. And currently, the British Academy uses a lottery-based approach for its small research grants. Both organisations report this experiment as really successful. The Volkswagen Foundation, from their website, say that they showed enhanced diversity, more early career grantees, more women, and more minority subject areas being funded. The scientists on the programmes eventually were highly acceptive of this lottery process within their community. And importantly, when the eventual outputs from the peer review group or the lottery selected group were compared, there were no significant differences in publications, in patents, and in funding or career effects. The randomised approach required much less input from other scientists, so that frees up scientists' time to focus on more productive work. And the British Academy is sufficiently happy with its adaptation of this process that it's extended its methodology until at least 2028. If the science is valid, a lottery approach might give you a fair shot at trying something new. So we're here today to discuss whether there's a place for public opinion in science. I contend there is not. And based on the admittedly limited current studies on the use of lotteries, I might even go further and say there is no place for any opinion in science at all. And I will leave it there.
Thank you, Professor Catherine Green. I might say clarify before the next speaker that in this House you are allowed to pose a point of information. So, for example, if the speaker says something within their speech that you believe to either be incorrect or ill-considered, you can stand up and shout on that point or point of information, and within that give a snippet of information or pose it as a question, and that's something that the speaker can choose to accept or reject, and from there they can then, of course, respond to it. But to then move on to our first speaker in opposition, we have Reema Patel. Reema Patel is a thought leader in the field of technology, data, and AI ethics, public engagement, participation, and diversity, equity, and inclusion. She currently leads global research agency Ipsos work on deliberative engagement. Reema has undertaken work at the cross-section of technology, ethics, public engagement, and diversity. She co-founded the Ada Lovelace Institute, where she establishes work on public engagement and participation. Reema Patel, you have the ears of the House.
Thank you so much. Thank you. Well, fantastic intervention, and I want to thank the proposition there for the most innovative use of space I have seen in a long time. So that really shows how it should be done. And I also want to say thank you, President, honourable members of the House, and friends in the proposition for this moment. It's a pleasure to be back in this chamber. I'm a lifetime member of the union, actually, and it's the first time I participated in a debate, so real pleasure for that. And the motion before us, which is about public opinion and its place in science, touches on one of the most important questions of our time for society today. And you won't be surprised to hear that I'm very much arguing that public opinion has a place in science. Why is that? In fact, what I'm going to argue is that science is people all the way down. That's the central point I'm going to make in this debate. The binary between people and science is false. What do I mean by science? I think that's important to think about. A really important point here is that science itself can be about people, and people were the ones who created, paid for, and shaped science. So we understand science broadly, not just natural science, but also social science, climate science, AI, healthcare. Now, in this very university, I study what was once called the moral sciences tripod. So here, we understood science is split into natural sciences and the moral sciences. And the Science Council today defines science as the pursuit of knowledge and understanding of the natural and social world following a systematic methodology based on evidence. It's social world. So in the early 2000s here, I read this moral sciences tripos, and many people have contributed and studied this tripos. Some of you might know names like Bertrand Russell, Ludwig Wittgenstein, John Maynard Keynes, once president of this union, and Amartya Sen, and they were all part of the moral science tradition and saw these inquiries as no less vital than chemistry or physics. So I'm not talking about discovery science, I'm talking about science in the broadest possible sense. Now, I want to note also my own ancestral traditions, the East African Indian heritage. A lot of that tradition is very much about practical ethics and understanding lived experience and incorporating that. So it's not just a Cambridge thing, it's actually an ancestral traditional thing I want to give a hat tip to here. And the union and this university, critically, have always honoured this broader view of inquiry, so I urge this house to do the same. Now, another point I'd like to mention is that public opinion need not be lacking or need not be without being founded on evidence and can shape evidence. So what do I mean by that? So we know about legal opinions, we know about medical opinions. What matters is what those opinions are founded upon. And a lot of the work that I do in the field of deliberative democracy is very much about ensuring that the public have the information to hand to be able to come to being able to determine certain judgments or value judgments here. But there are also other forms of evidence that the public might want to consider beyond the science. They might want to think about accessibility. They might want to think about affordability. They might want to think about how things affect them worldwide, and also really difficult trade-offs, difficult choices that policy demand. So science is one part of the equation, but need not be the only part of the equation. And I want to use climate science as a particular example to illustrate these points. So the science there is clear, the planet is warming and urgent action is needed. But science alone does not cut emission. Public opinion determines whether we fund climate research, whether governments legislate, whether businesses and people change. And the evidence here is really striking. So a recent global survey across 68 countries published in The Lancet showed that trust in scientists remains strong, and 4/5 of respondents want scientists to share their work publicly, and more than half of them want them to be actively involved in policymaking. So here, climate science demonstrates that public opinion isn't an obstacle, and Ipsos polling shows majorities in many countries already want climate action by governments and industry. So to say that public opinion has no place in science is reckless. Without engagement, the climate science will remain data in a report rather than an engine or a vehicle to drive change, as it must be. And I also want to say I was involved in running deliberations in Colombia, in Seychelles. In these places, public opinion shaped by lived experience can reinforce science. So communities that witness sea levels change, floods, heat waves, or glacier melting that provide invaluable and important knowledge that complements scientific models. And people who go about their daily lives capture photos of the real world and participate in science online, and this is a phenomenon known as citizen science. So when public opinion is based on evidence, it can drive treaties, renewable investment, and social transformation. And this approach to understanding public opinion is already happening, as I mentioned, through numerous deliberative processes, citizen jury and citizen assemblies, where there's a dialogue that happens between people, policymakers, scientists, and wider society. And I had the great honour of working on a public dialogue championed by Sir Patrick Vallance, really for the Committee on Climate Change and the Government Office for Science, where publics informed the government's net zero pathways for change. And that was a really interesting example of how this can happen. So even the scientific establishment recognise that facts alone cannot speak for themselves. They have to be carried and acted upon. And here, publics are absolutely critical to the impact of science. One other point I wanted to make is about the role of people in playing a key role in broadening and safeguarding science and the scientific method itself. So we often hear that policy and decision-making is guided by science. Now, I would like to remind you of some of the dynamics within the pandemic. I won't spend too long on that. That's a whole discussion in of itself. But wouldn't it be reassuring if that was actually true? In reality, the science can be shaped by funding priorities and politics, also be misused, recruited to justify decisions already taken. And I call this policy-driven science-making rather than science-driven policy-making. And as a result, we saw these discussions about herd immunity illustrative of that. And that's actually why openness and transparency matter so much. And peer review is, of course, an important part of that process. But arguably, it needs to be broader than just peers doing the review. So scrutiny and debate do not weaken science, they strengthen it. And I'd like to draw upon Karl Popper, who was a philosopher of science, who reminded us that in science and in general knowledge is something that advances by exposure to criticism. He called it epistemological pluralism. So here, public engagement is not a threat, but actually central to this process. And even Einstein began as a member of the public. He was a patent clerk in Bern before he transformed physics from outside the academy. And he encountered significant resistance from the academy itself for his theory of relativity, which illustrates how a fresh perspective and diversity of thought is exactly what is required to advance science and create paradigm shifts. So here, Einstein was a member of the public, and he was a scientist. And a little closer to home, we hero worship Watson and Crick for their contribution to the discovery of DNA. But we overlooked Rosalind Franklin's contribution because she was a woman. So how often have we hero-worshipped individual scientists without recognizing that without public support, public investment paid for by the public, and teamwork and collaboration, their discoveries would hardly have been possible? Is it possible that public opinion already shapes science and we don't give it the credit it deserves? Who benefits from science? A really last point here that I'm making. Who is science for if not for people and society? At the very least, people's views about its consequences matter. From deciding what is worthy of scientific inquiry in discovery, research and investment, to allocating significant research and development funding paid for by taxpayers, through to dealing with the consequences of science, we know that science is people all the way down. Oppenheimer could not ignore the public implications of nuclear discovery. And today, with artificial intelligence, biotechnology, and climate science, the stakes are no less profound for society as a whole. Excluding the public risks undermining science's legitimacy. So let us be clear. People already shape science, and without public opinion and engagement, science can hardly remain science at all. Accountable, open to knowledge, open to challenge and connected to society. The knowledge-based pluralism that is a necessity for the truly open society Popper imagined. Science already faces risks and threats, as the proposition outlined, and it is for these reasons, honourable member, that I urge you to oppose this motion. Thank you.
Thank you for your speech. We will now open up the floor to a round of floor speeches. So to briefly explain, floor speeches are opened up to the floor in where you'll be able to make a speech in proposition, opposition, or abstention of the motion. So to begin in proposition of the motion, if you do believe that public opinion has no place in science, would you like to stand up and make a floor speech? The gentleman in the front.
King's Trinity College.
Thank you.
And a life review. Madam Vice President, other UK members, I believe there are some, including the last speaker, and guests, I think there is a confusion about what this motion means. There are two ways of understanding it. Does public opinion have a place in the facts of science? And I would say emphatically no. Science is not a matter of opinion, it's a matter of fact. The science may change a bit over time, but the basic facts don't change, we simply get a slightly better understanding. James Clerk Maxwell thought he'd solved electricity and magnetism, and Einstein showed that in fact he hadn't quite solved it. Quantum mechanics came along. But Clerk Maxwell's electromagnetic theory is sufficient for most purposes, except mobile phones and computers. The other understanding, as expressed by the last speaker, is, does public opinion have a say in how science is used? That's an entirely different matter, and I agree that it should, but I don't think it's the motion.
Thank you for your speech. You will now take a speech in abstention. So if you either disagree on a point in the particular question, or you think we're not considering something in its full context, would you like to make a speech in abstention of the motion? In abstention? No one. We'll move on to opposition then. So if you oppose the motion tonight that this House believes that public opinion has no place in science, would you like to make a speech in opposition of the motion? In opposition? No one. Yeah, over there. Oh. Oh, would you like to?
Goodness knows how many decades ago I was at Imperial College. I would just make the point there is a difference between the issue of which science to be involved with and the implications of it, which I think the public needs to be very involved with, can't leave it just to politicians, and the micro decisions about what science means, which opinion, well, opinion has no place in science, I agree, but which results are more important than others, which results mean more than others, and so on. So I would say yes, public certainly has an opinion to provide in relation to macro decisions about science, but not on the micro decisions.
Thank you. And can we have your name and college as well, please?
I'm sorry?
Your name and college as well, please. Name and college.
Imperial College
Thank you.
of Science and Technology.
We will now take a final speech in abstention of the motion, or if we don't have anyone for that, then we are willing to take one more in either opposition or proposition of the motion. Would anyone like to make a final speech? The gentleman in the back.
Every day I take tablets, and that's because I have an understanding that they improve my health, and therefore I tacitly approve of them and support science. The other thing is that we know about global warming. If I turn down my thermostat, that is expressing an opinion about science. So I think that people, in different ways, if they contribute to a box going around to collect money for cancer research and they put £1 in, they are giving an opinion that they support the science.
Thank you. And can we also have your name and college as well, please?
At Wolston.
Thank you. So now we're going to move on to our second round of speeches, and just to remind the audience that points of information are encouraged and both allowed as well. So to begin, the first proposition speaker here is Professor Jeremy Barnberg. Professor Jeremy Bauernberg is a professor of nanoscience and the director of nanodoctoral training at the University of Cambridge. Jeremy Bauernberg is a clear leader in nanoscience and nanotechnology, working for much of his career at the interface between academia and industry. He has led interdisciplinary nanocentres at the Universities of Cambridge and Southampton, and developed novel devices within Hitachi, IBM, and his spin-offs, Meto Photonics and Base4. He is widely recognized as a leading innovator in nanotechnology, with his most recent awards being the Institute of Physics Faraday Medal in 2017. Jeremy Bauernberg, you have the ears of the House.
So I started my career in industry. I never any intention of ever being an academic in my life. And then in industry, eventually, so I was trying to make things. I'm interested in how light interacts with matter, making new transformational devices that we can use. But eventually I got sucked back into academia. And what was really interesting for me when I came to academia was that people complained about it all the time. So that's the main thing academics do is they complain about the system. They were complaining about they have to go to this conference, or so many scientists are interested in this area, so they only get funding in this area or not this area. But the really interesting thing about science at the moment is nobody told scientists how to make the system that they use for running science. It's actually entirely come from the bottom up, the way that we run the science system. So I became interested very much in this distinction that already some of the speakers have referred to between science itself, the creation of new knowledge, as my esteemed opponent has already defined. So new knowledge and the system of science, which actually I see as an ecosystem. So I became interested in it and actually have written a book about it. And I think the motion is very clear that it's talking about public opinion it has no place in science itself, the facts that one of the speakers from the floor was just talking about. So I'm going to extend and discuss some of that. So one of the things about the knowledge that we're creating as scientists is that knowledge is expanding. The edge of that expands at an enormous rate. Even scientists can't keep up with it, never mind the general public. So for the general public to have an opinion on science means that they have to have some way of scanning that, which is it's expanding at a rate where the information doubles every 3 years, and the number of scientists is still doubling every 18 years. I mean, it's an unsustainable rate of growth, actually, in how science is changing. So for that reason, I would really contend that public opinion has no place in science itself. But then there's an issue already, I think, referred to, is that scientists, of course, we're human people, I believe, and but also part of the public. So this system of how we do science, how we do experiments in the lab, try and analyze them, try and convince other people that these are really correct and worth believing, and our theories about them underpin what's going on. This is an entirely social construct. So indeed, what science gets done is sort of dependent on fashion and whim and conviction and the attention economy. But there's something amazing that we've created in this system of science is that we sift that. So all of that information gets sifted through this process. You've already heard about this peer review, but it's more than that. We create this sort of web of knowledge, and I always think about it like a tree. There's huge trunks on it that are supporting enormous parts of science. And when something comes out that it doesn't really agree with some of it, people are trying to find a place to put it in the science thing, it doesn't really fit there, and it sort of drops off if it's incorrect. So the amazing thing about the information that we're creating in science is it produces this incredibly robust structure that has no place for public opinion in it. It has no place for those scientists' opinion in it. It is this structure, this edifice that is completely cross-checked against itself. And this is very different from where public opinion can have a strong influence. Now, I'm actually you're going to hear from Lindsay a bit later. So you might say, well, what about the science of public opinion? That's what we might call sociology or social science. So isn't that the study of opinion? Isn't opinion have a place in that, surely? The difficulty about that, so that you may have heard about some of these issues of replicability in science. One of the difficult things about social science, as you might guess, is if you do an experiment on people at one particular time, when events have just skewed people's minds just this week, for instance, you'll get a very different result, or you might, if you do it in a year's time. So many of the social science experiments that people have done actually turn out to be very difficult to reproduce. So I can't, unfortunately, take this point without annoying people on my own side. But actually, I don't really think sociology and social science is a science in the meaning of this motion. That would be my contention. Because it has to be replicable science that adds to this web of knowledge. So, the facts. The other thing that, so now I'm a scientist here, but I also actually work for the research councils that we discussed at the start. So how do we spend this 8 billion a year that all of us are contributing to? How do we spend it wisely? So the first question is, this is for the public, right? What do you want? What should we spend our money on? Any ideas? So, why do we want science? So I think there's two main angles on this. One of them is sort of inspiration. We look up at the universe, the stars, we understand more about galaxies. It really inspires us about our place in the world. We start to understand, why are we alive? Why do we want to think about the world? What's in a worm? I think we had already. How does a virus work? So there's a very strong interest that we all have, a curiosity. I always say that, kids basically, where's the kids gone? Yeah, they always have an innate curiosity about the world. And they like to take it apart, and unfortunately we drum it out of them after years of education. But everybody is actually a natural scientist. The other thing that we really want from science is utility. So we want things from it. We want this gentleman's pills so that they work, they give him health. So I almost see this as two different angles. It's like it's a chart. And the difficult thing is you can't just decide to do utility. It doesn't work. What happens is, as we're doing science, we cycle backwards and forwards in this big plane between different aspects of the inspirational part, but then it turns out to have utility, which allows us to do new sorts of experiments which take us in completely new directions. And they combine with another sort of experiment, and back we go towards utility. So public opinion doesn't have a place in that sort of fact-based environment. On the other hand, we might decide that public opinion has some place in funding science. One of the interesting things about the UK is that you get the best bang for your buck that you're paying in the UK than anywhere else in the world. It's incredibly efficient about turning the money for doing science into this knowledge. We scientists would say it's because it's very badly underfunded. The Treasury think it's fantastic, right? We get the best. So it's not really clear what the answer to that is. But what's interesting in the UK is that we've had this principle called the Haldane principle, which says that the decisions about what science to fund really should be left to the scientists. So the Research Council was started in 1915 or so, and people talk about the Haldane principle, but actually you can't find any mention of it until the mid-60s, where people retrospectively said that, it turns out that's the system that we're using. We're using scientists deciding what science is done because it's the best way to fund science. And indeed, that's why public opinion can change where we hope and fear and are interested in science going, but it can't necessarily make the decisions about whether this is science we should absolutely do. Please.
I would believe that the Haldane principle being named after J.B.S. Haldane, first geneticist who was a professor here at Cambridge at one point. He, at various points, flirted with the idea of eugenics, as well as more traditional forms of genetics. If we do leave the decision of what kind of science to fund up to the scientists, how can we be sure that they are going to do it in ethical ways and not go down dark paths?
excellent point. Let's give him a round of applause. So the question is, the motion is, popular opinion has no place in science. I completely agree with you. It has a place in the science ecosystem, thinking how we do science, thinking which directions we're going to go into. So the interesting thing about Haldane is the Haldane principle is completely misnamed, and actually Lord Hailsham in the 60s decided that Haldane would be a good name to hang it on to, but he really shouldn't be associated with it. So we can remove the eugenics side, I think. I'm going to go back to this principle that my colleague raised about lottery as a way of deciding science. So one thing that we can imagine is a completely different dystopian way of funding science. We do the same thing. We look at all the ideas that scientists want to get funded, the things they want to do, and we decide, well, all these seem reasonably sensible. We can imagine they get somewhere with them, and these ones are really not going to make it, so we take them out. But then the way we're going to decide is by giving public the right decision, right? We're going to have a game show, right? So we're going to present to you, millions of people in the UK, these are the science projects we could do. Which are you going to choose? And you could vote. Is that going to be a good idea? So this is one of the scenarios I considered in the book that I wrote. And one of the things I could imagine, what's going to happen is, it's about the attention economy, the popular economy. So I'm actually going to hire an actor. I'm not going to present my science, because I'm not really good at presenting my science. I'm going to get an actor to do that. Actually, it's a company. They're going to have a great razzmatazz. There'll be fantastic graphics. And then, how are you going to decide realistically what science we should do? It'll be the one that's most compelling, not necessarily this general expansion into this area of inspiration and utility. So I would say this is the problem, and if you go that way, my learned opposition, the problem is we wouldn't have Wi-Fi, we wouldn't have generated vaccines, we wouldn't have made battery technology that we have at the moment, and in fact, I would recommend you to go home on your horses this evening after the lecture. So I would contend that public opinion really has no place in science. Thank you.
So to sort of move on to our second speaker in opposition of the motion, we have Professor Tim Lewins. Professor Tim Lewins is a professor of philosophy of science, the Department of History and Philosophy of Science. Tim is a professor of the philosophy of science at the University of Cambridge and a fellow at Clare College. Since January 2025, he has been the co-editor-in-chief of the British Journal for the Philosophy of Science. He is the author of 6 books, including The Meaning of Science and A Guardian, Book of the Year in 2015. From 2009 to 2015, he was a council member of the Nuffield Council on Bioethics and served on the working parties for 2 Nuffield Council reports. Professor Tim Lewins, you have the ears of the House.
It's an honour to be here. It's an honour to share some thoughts with you on this important debate. And I really would encourage you once again to interrupt me as much as you like. Since I'm arguing that public opinion is important, it would be ironic if I wasn't interested in listening to what you folk have to say. So let's be clear. Scientific work's demanding, it's technical. When it's done well, it's of immense value, and not very many people have the training needed to undertake it, just as you said earlier, Catherine. So that means, of course, there are important limits to the ways in which public opinion should engage with science. You won't get very far if you try to write an article on molecular genetics or on quantum mechanics by running out into the street and taking snippets of information from people that you poll at random, even though some postmodernists might advocate that. It's also important to note that some members of the public have subjected humble, hard-working scientists to appalling attacks. We've seen this from some extreme anti-vaxxers, for example, and there's no place for these attitudes. It's also deeply unhelpful when clear messages that emerge from the sciences are blurred, not necessarily by the general public, but sometimes by leading public figures who say things like, "The science is never settled," as though hard-won scientific wisdom were nothing more than an ink blot onto which one can project whatever views one happens to find politically convenient. But let's remember the terms of the motion. The motion doesn't say that the place of public opinion in science needs to be carefully delimited and controlled. The motion says there is no place for public opinion in science at all. And so if you think public opinion has some legitimate role to play in science, even if that role is constrained, you should oppose this motion. And it seems to me to be somewhat desperate to try to argue, as I think Jeremy just did, that science doesn't name the things scientists do, the institutions they work in, and the organizations that they belong to. It only names the body of fact that they're able to establish. But I'll come back to that, because I think public opinion even has a role in establishing those bodies of fact. Now, people like to argue in threes. And so at great risk to our case, I'm going to say that there are 4 substantial roles for public opinion in science. So the first one is, I think, the most obvious, and we've already talked about it. Public opinion is an important object of study. It's something that scientists need to find out about. If you want people to make use of valuable vaccines, if you want people to change their behavior in the face of climate change, you'd better understand why some of them are so hesitant. And unless science finds those things out, these problems will simply fester. And it's not true that only the social sciences suffer from problems of replication. Replication affects the medical sciences as well. It affects psychology. It affects studies in animal behavior. If your criterion for what counts as science is an area that's not subject to problems of replication, it's going to turn out not many people are doing science after all. Second, science does need to be understood, I think, in the context of democratic culture. So the kind of question that you might think democracy really does have something to say about is not fine-grained discussions about precisely which topics should be funded. That is indeed something that is often best left to the scientists and is sometimes well handled by lotteries, as a former PhD student of mine made a valuable case for a few years ago. Nonetheless, you might think it's very important to ask questions like, how much government funding in general should be put towards the sciences? To what extent should we instead leave science funding to the private sector? These kind of questions are very live right now when we're thinking about AI, control being left primarily in corporate hands. These questions are legitimately informed by public opinion in just the same way as any broad political question about funding, whether it's to do with defense, whether it's to do with education, whether it's to do with social housing, also needs to take some account of people's priorities without necessarily allowing for a straight veto. And sometimes public opinion really does have reasonable things to say, even about quite fine-grained matters of science policy. So let me give just one example. So cast your minds back to the summer of 2021, and what you'll remember, of course, is the JCVI, the Joint Committee on Vaccination and Immunisation, was considering whether to recommend extending the vaccine to teenagers, to adolescents. So this was the scientific expert committee advising government on vaccine policy, and the JCVI came to the view that the vaccine should not be offered to teenagers. They thought that the health risks from COVID to teens were comparatively mild in the context of potential side effects of the vaccine itself. Now, nonetheless, a considerable segment of public opinion pushed to reverse that decision. These were pro-vaxxers, not anti-vaxxers. They wanted the vaccine for teens against scientific advice. So what did the government do? They said, don't like those scientists, we've got more scientists for you. Let's see what the chief medical officers say. The chief medical officers thought again, and they came to the conclusion that vaccine for teenagers was justified. After all, what happened there? What happened is that the JCVI had used a very narrow frame of reference in the way it deliberated. It only considered direct health benefits to teenagers from using the vaccine. They didn't consider whether teens who were denied the vaccine might suffer in other ways. It wasn't on screen for them. Whether teens might suffer from having to miss school, for example, because they were self-isolating, because they hadn't been offered the vaccine. But these broader reasons to vaccinate were thought relevant by segments of the public. That was why public opinion was pushing for the vaccine. And ultimately, those were the reasons why the chief medical officers reversed the JCVI's initial decision. So here, a strand of...
The JCVI was not considering the validity of the science that said that the vaccine was effective. It was considering to whom the vaccine should be given. That is not a scientific matter, it's a political matter.
The question of to whom the vaccine should be given was, in the JCVI's terms, absolutely a scientific matter, because what the JCVI needed to do was try and figure out what the risk-benefit profile was to teens. And the risk-benefit profile of the vaccine is not going to be the same for all different age groups. If you're very old, the vaccine was very, very, very clearly in your health interests. The younger you get, the less clear it is. But the key thing here is, which benefits are we even going to include in the calculation? And the JCVI had a narrow view of that and was pushed by public opinion, in the end, via the CMOs, to making a different decision. And that seems to me to be a perfectly reasonable role for public opinion, because public opinion precisely drew the CMO's attention to this matter of the narrowness of the analysis. Now, you might not be convinced. This comes back to a point that you made earlier. So Rima talked earlier on about the problems of defining the key term science. We've talked about this already. Defining the key term public opinion. You might think the real term that we need to focus on, that we need to worry away at in this debate, is the term in. You might think the examples I've considered so far concern science's need for a social license to operate before it can get started in the first place, how it needs to engage with policy and publics once research is completed. But you might think none of this shows public opinion has a role in the design of scientific research or the weighing of scientific evidence. In that sense, you might think my examples don't establish any role for public opinion within the conduct of science proper. So let me respond to that with my third and fourth roles for public opinion. So research design first, the third role. So I'm lucky enough to be involved in a very exciting project that will take samples of ancient DNA from sites all around the world in order to try to reconstruct how ancient ecosystems have thrived or perished in the face of ancient climate upheavals. That kind of work is potentially very great value in helping us right now to build more resilient ecosystems in the face of our own climate crisis. But the opinions of local community members are essential if the design of this research is to be legitimate. What are the sensitivities of indigenous people about the sites chosen? Will the research design help to benefit these local communities, or will it only take from these local communities? Considered local opinions need to inform research design if it's to be legitimate. And now some of you still might not be satisfied. Science isn't about what scientists do. It's not about scientists at all. It's not about scientific opinion. It's just about facts. And public opinion has no role in facts, because public opinion is opinion, facts are something different. Now, there is a cheap way to secure victory for the motion. That's to define public opinion as ignorant, irrational opinion, and then to argue that the role of ignorant, irrational opinion can never be a constructive one. The public, I take it, are in fact those who haven't had formal training in science and who are not members of the formal institutions of science. But the opinions of these folk needn't be ignorant, it needn't be irrational, and sometimes it can concern the very facts established by the sciences. I'll give you an old example, I'll give you a more recent example, and then I'll stop speaking. Here's an old example. When Charles Darwin wanted evidence of both inheritance and variability in species to build his case in The Origin, whom did he ask? He asked amateur pigeon fanciers, because they knew what they were talking about, in spite of not being salaried as scientists and in spite of not having gentlemanly credentials. Here's a slightly less old example, still pretty old though. When the Chernobyl nuclear reactor exploded in 1986, radioactive fallout traveled across Europe and it landed on the hills of northern Britain. It landed in Cumbria. It was absorbed into the grazing cycle of sheep, but it was okay because the government scientists arrived in Cumbria and they told the hill farmers that they'd have to hold off bringing their sheep to market for maybe 3 weeks, but then after that the situation would resolve itself perfectly fine. Instead, the problem didn't persist for 3 weeks, it persisted for 26 years. So why were the government's estimates so spectacularly awry? Well, part of the answer here is that those government scientists ignored relevant knowledge possessed by members of the public, relevant knowledge possessed by local farmers, because they knew about the properties of the soil, they knew about the behavior of sheep, they knew about the organization of local markets. Sometimes public opinion is relevant even to the establishment of fact. So let me sum up. As an object of study, as a democratic legitimation, as a guide to good research conduct, and as an input into establishing the facts, public opinion has multiple places in science. You should oppose the motion.
Thank you for your speech. We are now again going to open up the floor to another round of floor speeches. So as mentioned, we will do one speech in proposition, one in opposition, and then one in abstention of the motion. So in opposition, if you do not believe that public opinion has no place in science, please raise your hand and I will select you for a floor speech. And this is in opposition. The gentleman there. And name and college, please, as well.
Steve Coburn from Emmanuel College. Surely science needs people like me to encourage my children to get vaccinated. Surely science needs people like me to do my recycling. So I need to be engaged with science. I can't be engaged unless I've got an opinion.
Thank you. And a speech and abstention to the gentleman in the back. Name and college, please, as well.
Partial. My college is IIT Kharagpur. So I believe science is about observing things and making a hypothesis out of it and then trying to either prove something or disprove something. Any member of the public can do that. Michael Faraday was able to do that by looking at the fields that were generated by magnets. Now, the problem is that even the public has, there is some signal out of all the noise that is coming out of public. It's very difficult to find a signal. And that's why the question arises, should the public have an opinion or not?
Thank you. And now, a final speech and proposition, the lady at the front. Name and college as well, or just name, it's fine.
I don't exactly have a college.
That's okay.
I think the motion of this debate is actually, I think public opinion already has a place in science, as we know it. As the gentleman said earlier, if I turn down my thermostat, that shows an opinion of public climate change. Oh, not public. Of climate change. And I think that if we already have, in some particular way, an opinion, a say, I think science research affects us. It is done for the public, it benefits the public, it affects us in our healthcare, it affects our knowledge, and I think we should have a say in the way that it affects us.
Yeah, thank you. And before we go into our last round of speeches, I will encourage one more floor speech in either opposition or proposition or abstention. If anyone would like to give one more, the gentleman over there. Name and college, please, as well, or just name is fine. That's okay?
I'm in opposition to this motion.
Yeah.
Along the lines of what Professor Mallow said, what our friend over there said, and his last speaker said, public science, unfortunately, does not and cannot exist without is necessary for funding it. Professor Lewin mentioned that we have, as a public, created this system where science can be done in an impartial way that produces facts to us. I think what science does rely on from the public is both its scientists. I mean, we teach science in schools both to produce scientists for the profession who require a public opinion that is, good science to push ourselves in the profession, and also to accept scientific verdicts. Furthermore, I feel that the scientific establishment requiring funding and requiring, it's a bit paradoxical, but a sense of public engagement to willingly step away from scientists' work and then go in and evaluate that work is a form of public engagement and a form of opinion in science. We know that we have to step away from scientists' work, but still evaluate it. It's the same thing. You may want to create the science behind proving climate change and turn it on those, but we do believe in it and we do have an opinion. And it needs to be put into practice in the real world, so scientists can then go back and look at it and say, look, we have this effect by reducing our energy output. This is low global temperatures, or if it doesn't, we need to think of a different way to talk about climate change. It is, I think the main point of it is that science benefits of this argument, is that science benefits from our opinion because we need to step away from it and then learn it as it has come up as a scientist saying. It's two sides. We've been talking a lot about scientists in this system because I think you are all scientists, but the wider public opinion around science validates your conclusions. Thank you.
Thank you. We will now move into our last round of speakers. So, the last speaker in proposition is going to be Professor Lindsay McGoey. Professor Lindsay McGoey is a professor of sociology with expertise in social theory and economic sociology. She is recognized internationally for playing a pioneering role in the establishment of ignorance studies, an interdisciplinary field focused on exploring how strategic ignorance and the will to ignore have underpinned economic change and political domination throughout history. Her research on ignorance has led to new conceptual frameworks for understanding the political value of ignorance and the unknown. Professor Lindsay McGoey, you have the ears of the House.
Thank you. When I first received the invitation to speak in favor of the motion, I was on the fence. It's a busy time. I'm a head of department currently. We're busy welcoming our students back to campus. Also, it is a rather controversial motion. I received the invitation to speak in favor of it quite late. I can't imagine why. People weren't exactly banging down the door to stand up publicly and say, forget about the people. They're quite demanding. Leave it to the scientists and move on. And then I thought a little bit more about the invitation. First, there was a personal element. The invitation came from one of my former PhD students. She's now a postdoc at Oxford, and I am very proud of her, and I didn't want to disappoint her. Plus, it's Cambridge. It's quite a prestigious way to pass the evening. So favoritism towards my student and the desire for prestige, I admit it, both of those factors influenced my decision, and I want to put a question to you all. What if everything in life happened for those same reasons? There are words that we should state openly when people make a habit of doing favors for people because they're close friends or their family. Words like clientelism and nepotism come to mind. There are also words for doing things because it looks good to others. There's sycophancy, hubris, fame-seeking, a fierce desire for public approval or validation. But some things in life, perhaps especially in the arena of science, don't always make you popular. Being courageous enough to state what you believe to be true and to evidence the reasons why, even if it sets you apart from the crowd or disappoints old friends or alumni, sometimes means that you don't have a lot of friends. Look at Thomas Paine, for example, the great English-born philosopher who inspired Americans to demand the right to vote and to govern themselves. When he died, it's reported only 6 people came to his funeral. Yet he is immortalized today due to his work through important essays like Common Sense. He fought against a belief that was commonplace in his time, the belief that concentrated power is the best type of power, and that absolute power should rest with monarchs who pass down their authority from heir to heir to heir. But an idea was forming which dared to say no to absolute power. Democrats insisted that the separation of powers is the only way to limit tyranny, and this separation of power applies to science too. Different branches of social, political, and scientific life must retain the capacity to act as autonomous checks and balances on each other. That belief led American founding fathers to draw on Montesquieu in forming the 3 branches of government. And it's the same hope today that still thrives in some areas of America, and leads even some on the political right to say no to Donald Trump when he tries to sabotage scientific independence. Make no mistake, often the trampling of rights comes dressed in much prettier language like public interest. Demagogues will use a concept like the public to oppress the public. It's the literal meaning of the word demagogue. And one of the ways to defend against that threat is actually, even if it seemed counterintuitive to you, even if it seems contrary to what you expected to think coming in here, one of the ways to guard against that concentration of power is actually to support this motion. Why? Because to defend this motion is to insist on the capacity to work as independently as possible from external forces that have a vested interest in scientific outcomes, in spinning science to self-serving advantage. That includes commerce and the effort, however difficult but still noble, to protect science from pernicious commercial profiteering that breeds mistrust and can distort science and its public uptake. It includes protection from undue government meddling, and it includes retaining autonomy from public opinion. Do I think that the public is a pernicious force? Sometimes. And let me defend why. Especially after a particularly gruesome or horrific crime, the majority of UK citizens invariably tend to support, whenever asked on opinion polls, the death penalty. Most probably would have said, and still do say, therefore, that the nurse, Lucy Letby, must die. Should she? Well, it is up to the judiciary and the people as well to decide that, but through due process, not due to an opinion poll. Is the public always pernicious? Well, I agree with Tim that we might try to score cheap points and say that it's because of the irrationality of the public that I feel that this motion should be supported. No, I will say the opposite. I will say, of course, the public is not always pernicious. Democracy, rule by the people, is the noblest form of government ever established and ever will be. Why? Why is it so noble? Why does it work? Because of the separation of powers. because we create internal borders between power holders to limit their capacity to corrupt each other. My colleagues and I are not making an anti-public argument. The separation of power is not an anti-public principle. It is the exact opposite. It is the humble admission of the fact that if we do admit it, sometimes we make decisions out of favoritism. And these shared collective selfish acts demands a more selfless system of governance to help to check us all, to safeguard us from groupthink or the pressure to conform. It's an admission of how little power any one entity should hold. Power separated is power subdued. And in today's world, we cannot let absolute power take hold again. The future of scientific inquiry, scientific independence, and I would say of human life itself, depends upon it. Thank you.
Thank you for your speech. Now, to move on to the final speech of the night, in opposition. That's how I think to do. So, in final opposition, we have Sarah Chater. Sarah is a trustee and vice president at the British Science Association. In her day job, she is the Director of Strategy and Policy and Joint Chief of Staff for UCL Research and Innovation and Global Management. She established and oversees the UCL Public Policy Programme to strengthen connections between UCL's research and public policy making. Sarah also co-founded and is the co-chair and director of programs of UPenn, the University Policy Engagement Network, where she's currently leading a $6 million UK RI-funded project to strengthen connections between academia and policy making. Sarah Chater, you have the ears of the House.
Thank you, everyone, especially to those of you who have stuck with us thus far. Before I get going, I want to pick up some of the discussion we've been having about how we define science. We've heard that science is the pursuit of knowledge. We've heard that it's about facts. It's also about the process of discovery. And it's about its use. And through that process, through its use, we in turn discover more and we add to the burden of scientific facts. So I see science in that holistic way. And I think, as we've also heard from both sides of the motion, this debate raises a fundamental question about what kind of a society we want to be. One in which science is detached and disconnected from people, or one where science is embedded within wider society. And given it's the Alumni Festival weekend, I want to take inspiration from one of Cambridge's most famous alumni, Isaac Newton, to answer this question. While Newton's laws of motion apply perfectly to objects in an idealized vacuum, in reality, objects are impacted by friction. In the same way, science does not exist in a vacuum. Thank you for stealing my line. It is impacted by public opinion. Science is a fundamentally human pursuit, as Rima reminded us. It reflects human ambition to push the boundaries of knowledge and to understand the world. It plays a crucial role in the expansion of knowledge, but it does so as a part of, not separate from, the rest of society. Science is inherently and necessarily shaped by societal values. One manifestation of this is the social contract between science and the public, which we've heard about. The public supports the scientific endeavour on the basis that it delivers benefits for society. This social contract underpins the public funding of science and the legal, regulatory and ethical frameworks in which science operates. It means there's a necessary democratic accountability that science owes the public. As Carl Sagan observed 30 years ago when he asked, who is running the science and technology in a democracy if the people don't know anything about it? To ignore the voice of the public in science is to risk fracturing that social contract. There's no automatic right to public funding and support for science. We can agree that science is necessary for human progress. We can agree it's a societal good, but it doesn't automatically follow that the public are obliged to fund it. Public support for science is not an entitlement. It must be earned. Please.
Albert Einstein was not funny. Isaac Newton was not funny. I could give numerous other examples. All of the fundamental discoveries that made the basis of modern science were not funded by him.
I accept that point as a historical fact, yeah. But I would also observe that neither of them, particularly Einstein, who was working as a patent clerk when he developed his special theory of relativity, were in fact salaried or formal scientists at the time. And now I think the question of how we fund and how we support and ensure that science continues in our society, I think public funding is very relevant, although you're right, it's not the only form of funding for science. But in terms of public funding, the UK currently invests about £20 billion a year in science. That's almost twice what is spent on housing. And it's in competition with urgent and growing demands on the public purse from schools and hospitals. In this context, I don't think we should kid ourselves that science is a doorstep issue. Why should someone living in Blackpool, earning minimum wage, worried about feeding their kids, looking after their elderly parents, why should they care about public funding for science? Why should they care about science? To secure continued public investment in science, and indeed to guide the private investment that also exists, we need to maintain public consent for that investment. And to be clear here, I agree with Kath. This doesn't mean giving the public a veto on what science is funded, or putting the public in charge of detailed funding decisions, or changing scientific methodology. As Tim said, there are limits to the role of public opinion in our science funding system, and the checks and balances that you've heard already reflect that. What it does mean, I think, is that science has a responsibility to listen to and to respond to public opinion. That can, of course, include disagreeing with public opinion, but disagreeing is not the same as disregarding. A disregard for public opinion risks fatally undermining public trust. This is not only bad for science, it has severe consequences for society. You only have to look at the current rise in misinformation around the world to see that. The ongoing debate around public health in the US, I think, shows us why sustaining public trust in science is so important. The increase in measles cases in the UK, some of which have been fatal as vaccination rates have declined, are a stark illustration of the very real human consequences of a lack of trust in science. And in contrast, a study published in Nature earlier this year found that those societies with high levels of trust in science and scientists actually dealt with the COVID pandemic more effectively because people were more likely to get vaccinated and more likely to comply with other policy interventions. However much science lauds objective facts, their provision to the public is worthless if people do not trust them. Yet how can the public be expected to trust science if science does not trust the public? Trust will not be developed if science turns its back on public opinion. It can only be built through engaging with public views on science. Perhaps what this debate is really about is who science is for. We need to ask ourselves whether we want science to be something that is seen as elitist or something which is for everyone and from which everyone can benefit. The British Science Association, of which I'm a trustee, believes that science is for everyone, and I hope that sentiment is widely shared. But ensuring that science is open to all requires engaging with public opinion. If we try to exclude it, we risk science being perceived as disconnected from and irrelevant to the public. Now, when my children, who you may have noticed here, were younger, if I said something they didn't like, they would cover their ears and tell me they couldn't hear me, la la la. Surely science can demonstrate more maturity than a toddler. We need to grow people's appetite for science. Thank you. I've embarrassed them, so thank you also for that. We need to grow people's appetite right across the country to learn about science, to think about science. We need to get them excited. And particularly important in terms of all of our future, we need to inspire young people to study science, as we heard from the floor. Public opinion isn't going anywhere. It will always be there, whether we like it or not. If we consider it to be ill-informed or misguided, then the answer is not to ignore it, but to engage meaningfully with those who see things differently, to build public understanding of science and to better inform public opinion. We must also remember, as Tim has told us, that knowledge isn't the sole preserve of science. Public inputs can in fact make an important contribution to the scientific effort and can advance scientific progress and innovation. You've heard some of those stories from Tim, but to add a couple more, in the 1980s, it was AIDS activists who pushed to increase investment in research for treatment and who also pushed to change clinical practice to speed up drug trials, leading to the development of successful treatment for AIDS in 1996, years before it would otherwise have happened. Citizen science has transformed the scale of research projects. Cornell University's eBird project has collected over 1 billion bird observations from volunteers all around the world and created one of the largest biodiversity databases ever. That's public input. In countries across the world, environmental activists and citizen scientists have driven research efforts to monitor air quality, which we now understand, thanks to those efforts, to be a very real threat to human health. And our understanding of our universe has been transformed by citizens, members of the public, contributing to studies of galaxies and stars. So there's an essential reciprocal relationship between science and the public, which drives societal and human progress. As Rima's unsung hero, Rosalind Franklin, wrote to her father in 1940, "Science and everyday life cannot and should not be separated." Developing a vaccine is of no use without people agreeing to be vaccinated, as we've heard from the floor. Providing evidence, as Rima said, on the impact of carbon emissions doesn't in and of itself cause people to change their behaviour to reduce those emissions. In other words, science is a necessary but an insufficient condition for human progress. Science alone cannot determine questions which are fundamental to how humans want to live in future. The development of AI, or genome editing, or the collection of personal data, they give rise to profound ethical questions about what kind of society we want to be. And unfettered scientific development, without consideration of how it impacts on individuals and wider society, and without taking account of public opinion, would be hugely irresponsible, would be reckless, in Rima's word, and not remotely desirable. So, in conclusion, science needs the public to ensure investment, to help drive innovation, and to maximise scientific benefits. But most importantly, ensuring a strong relationship between science and the wider public is how we ensure societal progress. It's good for everyone. Louis Pasteur wrote that knowledge belongs to humanity and is the torch which illuminates the world. Science does illuminate the world, and it is illuminated by the world in turn. And that is why public opinion has a critical place in science, and why I urge you to vote against this motion. Thank you.
Thank you to all for attending this evening, and thank you so much to our amazing speakers, who can all give another round of applause to. So, in this house, we vote by our feet. So what that means is, depending on whether you agree, so aye with the motion, or disagree, or nays, or noes with the motion, the doors at the back will open up. And then from there, you sort of walk through, and somebody will count your vote as you walk through the doors. So when you're ready to sort of walk and vote, you're most welcome to. Thank you so much for such an incredible evening. And please head upstairs to the library, where the bar is there, ready for the results soon. Thank you so much, and have an amazing evening.